In this video, we'll discuss circles in the coordinate plane. Let's begin by talking about equations of circles. Any good explanation of circles begins with an exploration of the distance formula. Let's suppose we have 2 points, hk, and another point, any other point in the coordinate plane, xy. And let's say we want to find the distance between those 2 points. We just simply use the distance formula, and that will tell us how far apart those 2 points are. Now, let's keep the distance between these 2 points fixed, but remember, xy can be any other point in the coordinate plane. And if the distance between xy and hk are fixed, notice that xy can only be points on a circle. One thing that we don't like very much when graphing things are square roots. You'll understand why a little bit later. So I'm going to get rid of the square root by squaring both sides of the equation. And in so doing, I find out that the distance squared is equal to the difference of the x-coordinate squared plus the difference of the y-coordinate squared. And as we can see by our animation here, that happens to be the equation of a circle where the distance between the 2 points is actually the radius of the circle. Now I want you to think about this. It's pretty deep. The equation of a circle is based on the distance formula. The distance formula was created by using the Pythagorean theorem. The equation of a circle is the Pythagorean theorem. How did right triangles become circles? Scary, isn't it? That does give us the equation of the circle. A circle with center hk and radius r has this equation, x minus h squared plus y minus k squared is equal to the radius squared. Now I do want you to pay close attention to these subtraction signs here. That means that the center is going to be the opposite of whatever is inside those parentheses. And we do happen to call this the standard form of a circle. So with that, ladies and gentlemen, let's go ahead and write some equations. Let's write the equation of a circle with center at -8, 4 and a radius 6. I'm not even going to bother to graph this because we happen to know the standard form of a circle. In order to write the equation, all that we need are the coordinates of the center and the radius. And, well, we're given the coordinates of the center as -8, 4, and we're given the radius as 6. So all that we have to do is plug those numbers into our equation. X minus -8 squared plus y minus 4 squared is going to equal 6, the radius squared. I'm going to simplify some of this, like minus and -8 is plus 8, and 6 squared is 36. And there is the equation of the circle. That is actually very easy to do. It's substitution property with a little bit of simplification. Let's make it a little bit harder. Here we're given a circle. The center is labeled as -2, 1, and we are given another point on the circle, -1, 5. But we're not given the radius. Oh no, what do we do? Well, remember what we talked about right at the beginning of this lesson? The radius is simply the distance between 2 points. So let's use the distance formula. So take our x-coordinates, subtract them, square it. Take our y-coordinates, subtract them, square it. Add that together, take the square root. We find out that the radius is the square root of 17. Do not punch that into your calculator. Don't do anything with it. Leave it as the square root of 17. And you'll see why in our very next step. You don't want to work with decimals. Trust me on this one. But now that we know the radius, and we were given the center, we can very quickly write the equation of the circle. We plug in the coordinates of the center, and notice that our radius, square root of 17, is going to be squared. So when we simplify this, x minus -2 becomes x plus 2, and the square and the square root undo each other, so we end up with x plus 2 squared plus y minus 1 squared is equal to 17. Okay, so if all that you're given is the center and a point on the circle, use the distance formula. Find the radius, then write the equation of the circle.